Hey friends, yep, still got the bandage on. That looks pretty bad, I guess. Yeah, I still don't know what is causing memory leak issues, and I want to understand. So here's where we stand now. I This was caused by a memory snapshot that I took, heap snapshot. What I'm gonna do today actually is change the way that I take heap snapshots. So hopefully this doesn't happen. I was trying to figure out what was going on with that little bump right there. And still, yeah, no idea. So what I want to do is explore this API because, yeah, this one, because I didn't realize that's a thing, and see if maybe we can avoid the jump whenever I take a heap snapshot, because I think that kind of messes with the results. So I believe I need to provide this flag. So what I'm going to do actually is I've got a simple node script here that I sometimes deploy just to like as a super simple but still Dockerized app with for Node. So let's do, and it uses SQLite. Or it has a SQLite database. I guess it doesn't use it. It does have a mount. Yeah, super simple node. Anyway, so what I want to do though is I just want to yeah, do this. Write heap snapshot, run this. See what happens. What the? That's funny. That emoji encoded in a funny way. Okay, so the question is, where does that heap snapshot go? Oh, right. Hold on. So they're given 3 options. Use the inspect flag, and then you can take a heap snapshot that way. I can't really do that on a thing that's running in production. Sorry, I'm just going to fix this bit. Or the command line flag, and then you run kill with yada yada. So yeah, I might not have to do that. Or I'm thinking these are ors. I don't think you have to do all these. Or you can say write heap snapshot. And we'll take a look at the docs. You need to have a way to invoke it without stopping the process, so calling it in an HTTP handler or as a reaction to a signal from the operating system is advised. Be careful not to expose the HTTP endpoint. Triggering the snapshot should not be possible for anyone else to access it. I've already got that set up on my site. You have to be logged in as me to be able to create the heap snapshot. For versions of Node before 11, you can use the heap dump package, which is actually what I'm using. So it looks like I can dump that. Haha, no pun intended. Or another option, trigger a heap snapshot using inspector protocol. Yeah, I don't think I want to do that. That looks more complicated than I'd like. Yeah, look at the positive deltas, explore references that cause them. Yeah, okay. So I think what we're going to look at then is write heap snapshot. Okay, so that's what's generated, which works great for me. But where does it go? Okay, returns a string. Yeah, it looks like it's synchronous, so snapshot. And there we go. Oh, there it is. Huh, weird. It didn't seem to, to save last time. Okay, so it is saving. All right, neat. And then let's just make sure that I can load those up. This is in desktop. Oh yeah, it is in Locker, but Locker, I don't think it has anything private in there, but you never know. So we're gonna just move it over so y'all can see it. I want simple node and heap snapshot. Open up. All right. There we go. And actually, you know what? Let's load another. Oh yeah, that's fine. We'll load the first one as well, and then we'll compare and let's see. Yeah, nothing different when in that view. I'm not sure how that differs from this comparison view. Comparison. Yeah, interesting. It's probably just luck of the draw, honestly. Certain things were garbage collected, others weren't, or something. Yeah, nothing of any significance. What is this delta number, I wonder? Okay, now this actually seems to have more information than the heap dump thing that I'm using now. So this is good news. And this means that it should actually be pretty simple to apply this to my site. Heap snapshot. And then, yeah. I wish that I could get the file name that it provides with the but I'll also be able to specify a directory. Because I like all of this stuff. Even thread ID and stuff, like that's great stuff. Hold on a second. Oh well. Expose internals of the heap snapshot. Okay. Expose numeric values in artificial field. Yeah, okay. I don't know about that, but I think what we're gonna do is we're gonna get the yeah, we're gonna actually just do this. Yep, that is it. We'll just stick it in the, I think it just goes in the current working directory. And that's fine. That gets blown away with every restart of the app anyway, so it's not a big deal. And that way I get the file name that I want. So that's nice. Okay, cool. Well, let's also npm uninstall heap dump. That'll be nice to get rid of that. Let's test this locally. Just, I don't know, it seems like a good idea. Yay, it's snowing. Okay, resources, heap dump. Heap snapshot. Not sure why this isn't displaying the text. I wonder why It seems to have failed loading the JavaScript, which should fade that in or something. I'm not sure. But here, let's make sure. Yeah, that's interesting. So it appears that with this, my server can actually take traffic while it's generating the heap snapshot, which is great. Definitely an upgrade. Oh, just kidding. I was generating the snapshot locally and using kentcdodds.com. Okay, let's try this again. Okay, so now I go local. Yeah, okay. It does lock up everything, which is what I expected. Pretty sure it wouldn't really work very well to say, hey, take a snapshot. But while you're doing that, it's like asking somebody to take your picture, but then moving really fast and they have a slow shutter speed. It just, yeah, wouldn't work. We need to pause everything, grab everything that's in memory, and then let it continue. So that's why it's synchronous. That's my guess. I don't know. I didn't build it. But that seems reasonable to me. That does seem to take a while, but it is what it is. Whoa, just kidding. Let's ignore those in case I ever do this again. So we want heap snapshot to be ignored. There we go. Dump, heap dump. And hopefully that works. Let's just load both of these. Oh, whoops, that was the one from the simple node. Never mind. Okay, now load from the desktop. And the second. Yeah, okay, so there were some things that happened between those two. So let's do a comparison. Look at the number of new strings, number of deleted strings, the number delta. So we created a lot more closures. That's interesting. I mean, what really probably matters more than all of this, the number of things, is the size delta, but I just thought the number of closures was kind of interesting. So within modules, I guess, created a bunch of closures, source map support. Yeah, this is running in dev too, so there's probably a bunch of other like dev-only things. Okay, anyway, so that's not what matters. What matters is the size delta. And we've got strings that added what looks like, come on, you're going to give me a tooltip that lets me finish that. I'm pretty sure that's the end, but that'd be 14 megs worth of strings, if I'm interpreting that correctly. We deleted a lot of strings, created a lot of strings, and ended up with 14 megs more. And most of it is source code. We've got a base 64 string here. That's for blog post images, probably. For the blurred version of the blog post images. Whoa, that was a mistake. Ah, rats. Good. Okay. Yeah, that pushed. So now we can look at the actions. I really think I should probably name it something better. And do it in a temporary directory too. Oh, right, and we want host also. Grab that. We want format. No, let's just use my utility for formatting the date. Except, you know what? I want format date and time. Do I have something like that? Okay, let's see what this does. If I pass, yes, that's what I want actually. Something like that anyway. Because you can't have colons in file names. And what are the other things that they put in there? PID and thread ID. I don't really need to know those things. Yeah. Yep. Okay, so we got localhost resources, heap snapshot, and that'll download. And now it goes into the temp directory, which is better anyway. Okay, we've got it, and it's formatted nicely. Oh, that's interesting. The host, so this is what it's called. Do you see that? It's localhost underscore 3000. Or here, I'll just do that. Oops. So localhost 3000, year, month, day, and then hour, minute, second, millisecond. And the time zone is going to be, because we got the offset as well. So that it should actually end up in UTC. So yeah, that makes sense. Anyway, yeah, so it looks like it actually automatically swapped makes the file name that you give it file name safe, which is pretty nice. Thank you. Okay, and it looks like it took 37 seconds to do that. Improve file name. Yeah, you can verify all you want. I'm not going to push this quite yet. We want to wait for this to act. Oh, it did deploy. Sweet. So let's go to Kenzie Dodds, build info, make sure we've got the latest build, dump, heap, dump. All right, resources, heap, snapshot. Here we go. And if I go to kenziedodds.com now and refresh, do a hard reload, then it's gonna take a moment. So that's the drawback here. Oh, that did not take nearly as long as I expected. So that's good news. It seems to be faster now also. So here, let's bring this down to 5 minutes. So that was the redeploy. I wonder if this happened because of the snapshot or not. I probably should have waited. But that is fine. So let's take another one. Resources, heap snapshot. See, now that's paused. 343. Okay, we got a little bit of a jump. That actually is to be expected as the site takes more traffic. So what I'm looking for is, I just realized my head is in the way. But what I'm looking for is for this to avoid it like a big jump of like twice as much memory, because that's what heap dump was doing. So I'd like to see if we can avoid that. Looks like it actually did double in memory, and it's unclear to me whether, maybe it didn't quite double, but it's unclear to me whether that's because of the heap snapshots I'm taking or because of just regular use as the app is booting up. So I probably should have waited a little while before starting to take these heap snapshots. But let's take another one. Actually, you know what? Let's give it a second. We will compare the ones we've got. This is probably not going to reveal too much of use, because this is just like, yeah, we're starting up. We're compiling more code. Where the heck am I using emotion? What are my dependencies? No doubt. Frame or motion. Yeah, okay. Yeah, interesting. Yeah, it's interesting. So we deleted 140,000 instances of compiled code and created 148,000 new ones for a delta of 7,000. Size delta of almost a meg. So yeah, there's nothing interesting in here. Yeah, and you can see that size difference there. I believe that indicates how much memory total was being used, maybe. I don't know. The site never gets quite that low, so maybe there's some other things like some of the other services running on. I wonder how much memory is used by my super simple node thing. Here, let me look at my Fly dashboard. I think I've got super simple node running. It does not appear that I do. Yeah, doesn't look like I do have it running. So here's what we're going to do. We're going to look at super simple node, simple node. Here we go. And we're going to get rid of this. We'll just do as simple as can be. And fly deploy. Fly create super simple node. I think it might be fly apps create super simple node. Right. We're going to get rid of that bit. just want to see what's the, like, for a crazy simple application that has no dependencies or anything, all it does is run a HTTP server. How much memory does that thing take? So we can find a baseline for what to expect. And we are using Node version 18, using Volta. I think this was generated for me. My Docker file is a little bit more complicated and does not use Volta or Debian directly. Maybe it should. Oh no, that's interesting. Oh, this was the new deploy. Yeah, that's what's going on, because I pushed the improve file name thing. So we dove down. Half tempted to take a snapshot right now, but I just want to give it a little bit more time to get some traffic from people, have people change the theme, go to the blog, read blog posts, that sort of thing. Can you believe how freaking fast this site is? Ah, man. It is so crazy fast. Once I fixed that caching issue that I had. Oh, that was fun. Did you know every time you refresh this page, these people are in a random order? Yep. I think that's cool. All right. So we are going up just a bit, 337 up to 347. Where are we here? Yeah, okay. Let's take a look at this. So metrics, if we go to super simple node .fly.dev, we've got Kent site is having issues. Emoji encoding funniness, standby. Okay, cool. So now if I go to metrics, and we're looking at, holy freak, 23 megs of memory used in a super simple node baseline. Okay, now that's interesting. 65, probably once it took traffic. So, okay, that's interesting. Okay, yeah, 65 is probably where it sits. Wonder how fast that is. If we look at network performance here, 31 milliseconds. Unbelievable. 29, 38, 30, 31, 34, 31, 28. Here, I'm going to, just for funsies, this is the simplest server I could imagine. Let's make it as simple as possible. Boom, boom. What does write return? let's see, this would be the response. Returns Boolean. Yeah, okay. We're going to just make it a crazy small, as small as we can, code golf this thing. I could probably make this smaller, but then we're getting to like ridiculous territory. Oh, say port is oh, whoops. Fly deploy. And when that's done, you can update my fly version. Okay. All right, so the last 15 minutes, we let's look at the last hour. Huh. Yeah, okay, so we were sitting happy. I redeployed and stuff, and then it was, sitting around. Like, it wasn't, there was no memory leak. Like, maybe I don't have a memory, I don't know. I'm confused. It does seem to, like, increase over time, though, right? Like, that is increasing. And then, yeah, see right there. So, like, by the end of this, it was 626. It started out, this was a snapshot bump, and then I guess it dropped. I'm not sure. I can't remember. That was last night. Did I deploy last night? I can't remember. I definitely deployed this morning. Feels like I deployed this morning. Anyway, yeah, I was at 500 after this little bump. I'm not sure what that bump was. I looked at the logs. I am keeping logs upstairs on my computer in my room. Excuse me. And I looked, and nothing out of the ordinary happened there. So I have no idea where that bump came from. But that's 100 megs of, like, who knows what was happening there. I really don't know. There was a page that was compiled. That possibly could be it. Like, maybe we're not reusing existing instances of some of the tools that we're using to compile pages. And so we hang on to old ones. And I have a cache, so we don't compile new pages all the time. So maybe I should try to, like, hit it and say, okay, compile it again, and just see if that increases. It'd be really helpful if I knew what interaction had caused memory bumps like that. But anyway, it did seem to increase over time, and I just wish that I had some idea what is causing that. So, in the last 15 minutes, though, we deployed a couple times, had a little bumps and stuff, and this was the last deploy. So now, I'm going to take another snapshot. We're going to delete these. I can't see the odds. Actually, yeah. Let's just double check that. Improve file name. Yep. Okay, resources, heap snapshot. Did this deploy successfully? Yeah, it did. So this little dip was probably when it deployed. Yeah, that was about 2 minutes ago. So yeah, it's sitting at 64. This must have been just when it was barely starting up, but the node server wasn't running. So looks like bare minimum fly is probably around 25 megabytes. And then you add a node server running, and now you're looking at another 40 megabytes-ish. Yeah. blows my mind how fast this is. What region am I in? Here, let's pretend I want it to go to India. So, nah, that can't be. It's probably ignoring my request header. It's gotta like get to Fly's Edge network, and it's like, you want to go to MAA, but we don't have a region in MAA, so I'm gonna send you to the closest region. That's probably what's going on. So here's what we're gonna do to really test this. We're gonna go to webpagetest.org. And we're going to do Mumbai start test. You know what? Am I logged in? Well, let's log in so we can keep this test around for a while. Let me move this over and log in. That is not what I wanted. There we go. Start test. And then let's also do and just for the heck of it. Huh, that's weird. That is not formatted the way I expected, but whatever. Wonder how many test runs, is that like per month or lifetime? Yeah, it runs per month. Yeah, okay, good. That is just fine. Okay, cool. So this is in India. Can't really see when it actually shows up, but there's no content layout shift, that's for sure. First byte is after a second 0.7. So, yeah, not bad. Interesting. Okay, then in Virginia, yeah, that's fascinating. It's on 4G, this is on 3G. So we'll look at what cable in Germany says. Oh, it's waiting behind 23 other tests. Good grief. Wait, in Salt Lake City. What? No, I wanted Germany. Whatever. I'll just cancel that one. Anyway, I gotta take a break. So we will. That does seem interesting. I am gonna just, yeah, gonna take the break now. Gonna jump on Twitter for a sec to share some stuff. See you in a minute. Okay, finally over. Just took me a second to tweet that. I guess I will link to that tweet in the chat, so y'all can see it. So yeah, if you were unaware, I ignore YouTube chat because over there because the moderation there on YouTube is no good. So check for a link in the description to find the chat. All right, sweet. So let's do this again. Here, let's first check our metrics. So we're pretty steady at 680. Huh. Oh, what the heck caused that? 129. Okay, I'm gonna be right back actually, because I want to see the logs. I wish I'd been running logs locally. I've got it running. Here, we're gonna do that now. There we go. Yeah, so I'll have those running here. But yeah, I want to go grab that other machine and just look at those logs. What caused it to double at 129? What was it doing 15 minutes ago? That is the question. So I'll be right back. Should be pretty quick. Okay, I'm back. I just stuck the relevant logs in a note that I can copy over here. Where is it? Oh, did it not save? Man. It looked like it saved. Oh, you gotta be joking. For real? Okay, golly. I'll be right back. Okay, now, was I, you know what, maybe I was looking at the wrong account. That could be. Nope. Where the, what? I even confirmed that it's saved, so what the heck? Good grief. I realized I was saving it to the wrong account. It was to my wife's account. Whoops. Sorry, Yen. Okay, here we go. So let's take a look at these logs and see if there's anything in here that can tell us why we got a memory bump. Okay, probably not there. And the time of the bump was at 129. Between 129.30 and 129. So could have been caused by something that happened like a little before. This is interesting right there. It probably didn't happen. Oh, now here's something interesting. That heap snapshot finished. Did I take a heap snapshot at that time? Oh, I did. Well, that explains it. Okay, yeah, that's what it was. I don't remember taking a heap snapshot, but this heap snapshot was started at 28:49. Yeah, and you'll notice that right there, 28:46, nothing happened till here. Looks like it managed to start serving traffic, and then this download finished. Yeah, so all of, whoops, so the snapshot started right after this request start, and then download start happened here, and then it was able to take more requests, and then the download end. So everything between these two is what was happening during the download. Now this query route call aborted is interesting to me. It's probably because they've got a timeout on this, and so when JavaScript was able to pick it back up, it was like, oh man, I gotta call this timeout, and it's like, oh, you timed out. Something like that. I don't know. Seems reasonable. So I'm not going to be too concerned about that. All right. So with that all worked out, that bump came from a memory measurement. So my question is, maybe there's huh. Startup snapshot API. Interesting. Huh. All right. Well, I guess let's take another snapshot. I don't know. Yeah, so we'll take another snapshot. We'll see if my node process has, if the new snapshot is twice as big. If it's not, then that's telling me that node isn't the one that's hanging on to all this memory, but it's some other process or something, I guess. Okay. Now, let's about blank. Memory load. Load that one. Load this one. So we're looking at, yeah, 3 megabyte difference. So yeah, it's definitely not including all of this stuff. It's just the snapshot. Taking the snapshot itself somehow increases the memory and it's never freed up, presumably. Here, let's see if I can get something. Was that in the last 15? Ah, dang it. It wasn't. I'm just hiding that that bumpy ride right there, so that this bit isn't distracting. And we're gonna go to Twitter here. Firecracker memory usage, showing a bump in usage of twice as much memory at around 1:29 p.m. Anyone know why calling write heap snapshot, where are you? V8 write heap snapshot would cause my VM to use twice as much memory I have some ideas. What I don't get is, I think I know why, but what I don't understand is why it remains at that level of memory instead of freeing that memory up once the snapshot is saved. Okay. See if people have any idea. That's just bothering me. It's not really a problem. What's interesting is, I should probably add this context. An interesting note is that subsequent calls to write heap snapshot do not trigger or do not do this. Sometimes it seems to. Yeah, I feel like it has before, actually. Maybe even the last 2 days. No. No, I don't think it has in the last 2 days. I'm not sure. So maybe it just keeps the snapshot in memory until you take another one, at which time that the old one goes away. All right. Anyway, yeah, it looks like there's nothing really significant between these two. I probably won't be able to determine anything useful. So what is the difference between the comparison and the summary with objects allocated between? That's 4% of all the objects allocated after that time, maybe? I don't know. If I click on this and then I click on this, does that change at all? Yeah, it does not. Okay. So I think when I say this is 4% of whatever is in here. And so when I select this one and I have that filter, it's like, well, I don't have any objects that are allocated between these two because I am the first one. I don't have any of the new ones. That's probably what's going on. So for that reason, I think that this should actually look the same. Here, let's look at distance of 65. We've got async resource and a board controller. Let's see what happens if we go comparison. And then, oh, it doesn't say a distance. Rats. Oh well, pretty sure the same data is in both of these, the comparison as well as the summary of the between objects allocated between those times. Anyway, this is just going to be 2 megabytes right there, and it's compiled code. Looks like we deleted a bunch and created a bunch of new compiled code. What does that even mean? The constructor is compiled code, so I think that is stuff that does not have a constructor, maybe? Yeah, I have no idea. So we got internal array, regexp data, constant pool, scope info, code for blog home. Oh, that's interesting. Huh, okay, well, I think we're gonna need to wait again. But now we at least have a better heap snapshot tool, hopefully. I mean, at least it now also gives the number of items and stuff, so it's more up to date. for taking heap snapshots. So there you go. Okay, I'm gonna take a little break, and then I will jump back on and stream the rocket rental. We're gonna get back into that. Let me just move this over. Let's get rid of this. Let me close this. Yes. And yeah, I think that's it. All right, thanks for joining me on this basically fruitless quest of figuring out why my app very, very slowly increases in memory usage. That is just really confusing to me, but it is what it is. So yeah, I'll start up here in a couple minutes for Rocket Rental. See you all soon.